This is about the cardiovascular system. Sometimes people call it the circulatory system. I do that sometimes. You can too. It's a free country. But either way, we're talking about the heart and the blood vessels and the blood that runs through them. And it's all about transportation of things. Things need to go places. The cardiovascular system makes sure that it gets there. One important note to mention for those of you who have been heartbroken before, that includes myself, your heart will not actually break if your boob breaks up with you. It won't. Thankfully, too, because it's kind of an important organ here, the heart. But yeah, this video is about the circulatory system. I talked about transportation, and that's what it's all about here. Things need to get to cells, like oxygen, like nutrients that get into your blood via the digestive system. They need to go places. The cardiovascular system is going to get them there. Okay, so your cells need oxygen for energy. They need nutrients to use for the building blocks of proteins and other things. Your lungs actually need CO2 so we can get rid of that waste product of respiration and other wastes potentially that may not leave through the lungs but through some other avenue that we could talk about later. But yeah, things need to get places, oxygen to your cells, CO2 to the lungs. So how does that happen? It happens through your blood and your bloodstream. So that's the main job here. It is a pressurized system. You can think of it a lot of it like the respiratory system that you just learned about. Air will move from high to low pressure. This is similar, except instead of air moving, it's blood moving through your body in that pressurized system. The heart is the pump of your circulatory system. It's really the thing that powers everything in the movement and the transportation of blood throughout your body. Alright, so there it is, that big beautiful thing. It's about the size of 2 fists put together. It's oriented slightly to your left-hand side, but really it is almost right down the middle, right in your chest. With each pump, about 5 liters of blood will move through your body. 5 liters. In your heart at resting, you have a heart rate of approximately 60 beats per minute, probably a little bit more at your age. So that translates into about 100,000 contractions of your heart, 100,000 beats per day, about 35 million per year, and then about 2 to 3 billion in your lifetime. That is quite a muscle, and it's got quite a job. One thing that you'll notice, you can listen to your heart, actually. There are 4 different chambers, the 2 atria, the singular form would be atrium, and then 2 ventricles, the left and the right ventricle, are the 4 chambers of your heart. Not all animals are lucky enough to have a 4-chambered heart. We do. You'll notice the white things in these pictures are the valves of the heart that allow, they stop blood from leaking into other places, but when they open, they allow that blood flow to go from one atrium to a ventricle and to the system or to your lungs, and we'll talk about where that actually happens. You can actually hear your valves opening and closing. It kind of sounds like this. That lub-dub is simply your valves opening and closing. That first lub sound would be when the atrium, or these valves right here, allow blood into the ventricles, and then that second dub sound, the lub-dub, goes either to the lungs or to the aorta and to the rest of the body. So yeah, you can actually hear that happening the 2 to 3 billion times that it does in your lifetime. Okay, let's start here. We're going to start with the left ventricle. This is the largest, it's huge, enormous part of your heart. The greatest pressures exist in the left ventricle, and you'll notice that the wall of it, including this dividing septum between the ventricles, has the thickest muscle. It's got probably the most difficult job of the heart, or at least most physical. It needs to pump blood that has oxygen in it to all the cells of your body. That's a big job. So the left ventricle is where we're going to start. When that contracts, it's going to send blood up through here to your aorta. Now, quick story time here. I had the opportunity to go to this scholarship competition at Luther College. I ended up going to Augustana College, which is probably the best college you'll ever hear about or go to yourself. But at the scholarship competition, it was kind of cool. They had some different exhibits and different ways to look at what the college had to offer. I chose the biology route, and the option there, you got to actually see a human cadaver. A cadaver is a dead body. So I got to see one, and we got to open it up a little bit. It had been open and studied before. It was just me and a professor and a girl, and I thought, I got to be impressive here. I got to impress the girl and the professor, of course, and show them that not only that I was interested, that I was tough enough to handle and stomach everything that I'd see. And I did pretty well with that until they had a picture of this guy's aorta, or an artery directly after it. And there was, lodged in there was a huge clot that he started moving around. And at that point, that's probably why the guy had died. And maybe I thought of my own mortality at that point, and I thought, oh, that's pretty gross right there. And I started to lose the blood from my head. Apparently, I turned white. My ears started ringing, and I was standing there really lightheaded. Everything started to turn black. I think I was on the verge of fainting at the point that, but I was going to tough it out. I'm me, and I'm 6'3" dude. I'm pretty tough, right? And the girl was just fine. And the professor obviously is just fine. He had been around it a lot before. But I was trying to tough it out. And at that point, I think I couldn't hear hardly anything with the ringing in my ears. Definitely couldn't see anything. But I did faintly hear, hey, do you want to go sit down, maybe? And I was like, yeah. And so I did, and I just remember that always as that was a lot to take in maybe at that point, but just a random story there. But yeah, it was in this guy's aorta, and it was enough to experience right there. So after it goes to the aorta, it's going to go into your blood vessels, and a lot of different blood vessels at different times. Now, this is where we've got to get all this oxygen to the cells that need it. So it's going to go through these arteries, and these arteries are very thick-walled. They're very thick-walled, they're very large around, and gradually they split off into smaller and smaller blood vessels, arterioles, that again are carrying oxygen. And then eventually around the cells there are capillary beds. These are microscopic blood vessels in which the diffusion of oxygen will go across the membrane into these cells, and so that oxygen can be used. After that, the blood vessels, these capillaries, no longer have oxygen in them, and they need to begin the process of returning to the heart. So arteries are always going away from the heart. veins will bring the blood back to the heart. And here it's the opposite. You start pretty very small circumference of the blood vessel, and then it gradually gets to larger and larger veins as we get closer and closer to the heart. One big difference between arteries and veins, besides the direction of flow, is that the veins will have thinner walls than the arteries. They also have valves inside that prevent backflow, so that it helps get the blood back to the heart where it needs to go. Okay, so that is the systemic circuit that takes oxygen to the cells and then brings back carbon dioxide, which is a waste product of respiration, back to the heart. Okay, so we're getting back to the heart. Here are a couple of veins we should know. The superior vena cava is going to drain all the blood eventually from your upper body back to this chamber of the heart. The inferior vena cava will bring in blood from your lower body back to the heart. Okay, so now we have blood coming into this right atrium. I should say something about the right and left. Hey, Mr. Hoig, isn't the left over here and the right over here? That's actually wrong. You're talking about this person's heart as if you were looking at it from your perspective. Okay, so that's the view you have. So this guy's, from his perspective, his left is over here, his right is over here. Okay, so blood is coming in, returning to the heart. It doesn't have any oxygen. It's got a bunch of CO2 instead. It gets to the right atrium. When these valves open, it allows blood flow into the right ventricle. At that point, when the right ventricle contracts, the blood will go back to through these pulmonary arteries, and that will take blood to the lungs. Okay, pulmonary is kind of referring to lungs. So from the right ventricle, blood will flow in the pulmonary arteries to the lungs. You've seen this before. Here's the blood coming in. It's got CO2, drops it off, goes across the membrane by diffusion, picks up the oxygen that came from the air in the airway, from the alveoli, and now this blood is awesome and it has oxygen. So let's keep going, blood. Here are your pulmonary veins. So from the lungs are these pulmonary veins returning blood back to the heart, and after it comes back through these pulmonary veins, it will enter into the left atrium. Okay, so the left atrium receives this blood, and then left atrium, all it has to do is pump the blood to the left ventricle, so the left ventricle can put this wonderful oxygen-filled blood to the rest of your body's cells. Okay, so that is the story. It's time for school to get out. All right, but we're done. That's the story of the circulatory system, the cardiovascular system. Thank you for being here.